Hi everyone. Today we're talking about area of a triangle. We've already talked about rectangles, squares, parallelograms, and trapezoids. So next in line is the triangle. This first little segment I'm going to do, you could take notes on your sheet that says where does it come from. So that blank sheet that talks about area of a triangle, and I'm going to try to demonstrate for you where this formula comes from. I bet most of you know this formula already, but just in case you don't. So I'm just going to start with a generic triangle here. Okay, nothing real special about it. Just a triangle. And similar to what I did with the parallelogram and the trapezoid last week, I'm going to take that triangle and duplicate it. So now I have two of the exact same triangle. And what I want to do is I want to line up two of the congruent sides. So I want to line up, like, for example, this side with this side. So I will take this second triangle and flip it over. That looks good. Okay, I'm going to pick this up, carry it over here, and voila. Let's take a look at what's formed by these two triangles. When I look at the outside figure here, what I want you to see is that when I take those two triangles and line them up together, it forms a parallelogram. So we already know the area of the parallelogram is base times height, where this is the base, and then the height would be, thinking about the best place to draw in the height. The height would be up and down like this. And I could have drawn that height in here anywhere. I could have drawn it here, I could have drawn it here. Remember, the important thing about the height is that it always makes a right angle. So the problem here is, and this is similar to what we did with the trapezoid, I don't want the area of this whole thing. What I wanted initially was the area of just this triangle, but now I have two of these triangles here that I could find by doing base times height, but I don't want that whole thing. I want just this, which is half of this figure. So for my area of a triangle, I'm going to take that base times height and divide it by 2, and that cuts out this second triangle. Okay? So in your, let's go to your purple sheet, your purple formula sheet, and write this in for a second. So this is with next to triangle. And we're going to write this formula two different ways. You could think of it as base times height divided by 2, which is the way we sort of came up with. Or the other way you're going to see it written is 1/2 base times height. Because multiplying by 1/2 is really the same as dividing by 2. So these two formulas actually say the exact same thing. What I want you to do in the space where you can draw your picture is we're actually going to draw 3 different pictures, because I want you to recognize the height no matter what the triangle looks like. Draw me an acute triangle. Draw me a right triangle. So this is a right angle. And then draw me an obtuse triangle. So like I said, I want to make sure you understand where the height is no matter how your triangle is drawn. If your triangle is in an acute triangle, your height is going to be probably inside of the triangle like this, at a right angle. So this would be your base, and this would be your height. If your triangle is a right triangle, that's convenient, because this is your base, and then this side of the triangle is your height. So notice over here, your height was not a side of the triangle, but in this right triangle, the height is the side because you've already got that right angle there. When you have an obtuse triangle, and this is what I was struggling with in that last picture, the height is actually going to be outside of the triangle, because that's the only way that you want to make sure when you're measuring height, you go to the highest point you can of the figure. So notice, like here, this is the highest point in the triangle. Here, this is the highest point. Here, this is the highest point. But if I were to go inside here anywhere and try to draw in the height, I wouldn't get up that high. So the only way to draw the height is to go from here straight down at a right angle, but it doesn't actually touch the base. Okay, it's the same line that the base is on, but the height is outside of the triangle. And then for the base, you're still just looking at the length of this side. Okay, so you're not measuring this piece here. This would be your base here, and this would be your height. So I would draw in all three of those scenarios, because you're going to run into all of those with these area problems. Okay. All right, now I'm headed back over to your notes packet, to the examples that were on the back of your where did it come from sheet. So find your way to the first example. Should look like this, but I'll give you a minute to flip there. So looking at this triangle, I know that to find the area, I'm going to do base times height divided by 2. And remember, your base and height are always going to form a right angle with each other. So looking at this figure, I see my right angle right here, which means the 5 and the 6 are my base and my height. Doesn't matter which is which, okay? As long as they make that right angle, that's the important part. The 7.8 does not help us in the least for doing area. Okay, the only ones I care about are the ones that make the right angle. So for this particular triangle, I would do 5 times 6 divided by 2. That's going to be 30 divided by 2, which is 15 square inches. Okay, so really the trick to that one was just knowing which ones were the base and the height. Okay, a right triangle has legs 2.1 and 3.9. What is its area? Well, this is really the same as the last problem, it's just not drawing the picture for you. We know it's a right triangle. And I'm not sure if we've talked about this terminology before or not, but the legs of a right triangle, oh, I think we did back in congruent triangles, but the legs of a right triangle are the two sides that make the right angle, the ones that make the L, like L for legs. So that means that these two sides are 2.1 and 3.9. Doesn't matter which is which. Okay? Because when I go to do the area, and I'm doing base times height divided by 2, I know that these two numbers have to be my base and my height because they make a right angle. So all I have to do is 2.1 times 3.9 divided by 2. And it's going to take me a minute to calculate that, so you start typing away and see if you can calculate it. Alright, for 2.1 times 3.9, I get 8.19. And then divide that by 2, 4.095. And because this is in meters up here, I'm going to say this is square meters. Okay, on to our next one. Find the length of the base of a triangle with area 25 square inches and altitude of 10 inches. By the way, altitude is another word for height. You're going to want to know that. So I don't know what my triangle is supposed to look like, so I'm just going to draw any old triangle I want to. I know the area is 25, and the altitude, which is the height, is 10. And I'm trying to find the length of the base. Well, if I set this up with my formula looks like this. A equals B times H divided by 2. And I'm going to plug in whatever numbers I can. So I know that A has to be 25. I don't know what B is, so I'm going to leave that as a B. But I do know what h is. My h is a 10 divided by 2. And I want to solve this for b. A couple different ways you could go about this here, but probably what I would do is do this 10 divided by 2 here. And that's going to give me 25 equals, really this is b times 10 divided by 2 is 5. So this is going to be 5b. Divide by 5 on each side. And I get that my base must be equal to 5. Okay. So the length of my base must be equal to 5 with a height of 10 to get a total area of 25. Last one, area of this triangle. Okay, so length of my base is going to be this side here, and then my height is going to be straight up and down here. So length of my base, that's along the x-axis. So I'm looking at my x-coordinates, that's -7 up to +3. The distance between -7 and 3 is 10 units. If you're not sure about that, you could do -7 minus 3 or 3 minus -7. It might come out negative depending on which way you subtract. But remember that you can't measure distance with negative numbers. So even if you get -10, the distance is still just 10. Now this is going up and down. This is on the y-axis. So to find this distance here, I want to look here and here at my y-coordinates. Again, because I'm going upside down. So I'm sorry, not upside down. Up and down. I'm going vertically. So my y-coordinates are 6 and 0, which means that's a total distance of 6. So when I go to find my area equals base times height divided by 2. So that would be 10 for my base, 6 for my height, divide by 2. That's 60 divided by 2, so that's 30 square units. I think that's it. That was our last example for triangles. So now you are headed over to lesson 8-4, which is listed on the back board. It's also listed in your assignment calendar. All of those problems should pertain to area of triangles. We will take a look at this assignment and your assignment from yesterday when I'm back tomorrow. Okay? If you do have questions, you are welcome to email me, work together in class, try to work through as many of these as you can. Hopefully you have a good amount of time left.